Good morning, everyone. My name is Ms. Spector Kane, and I am a teacher at Denton Magnet School teaching 6th grade advanced mathematics. Today, I'm going to do a lesson with you on the surface area of a rectangular prism. I'm so excited about being here, and I'm going to get to do one of my favorite lessons that I thought I was going to miss out doing with my students. But now I get to do it with everyone in the county. So we're going to start off this morning by just figuring out some definitions and terms. Our essential question today is, how do you find the surface area of a rectangular prism? We have some vocabulary: surface area, net, rectangular prism, and we're using the Alabama Course of Study Standard number 22, which is finding the area of a rectangular prism. So we're going to start with our vocabulary this morning. What is a rectangular prism? It is a 3D solid shape with 6 faces. A face is simply the piece that makes up the shape. It has a top, a bottom, 2 sides, a front, and a back. Front, bottom, top, bottom, 2 sides. That makes up the 6 pieces of a rectangular prism. All rectangular prisms must have 6 pieces. What is a net? Yes, we can have a basketball net, but that's not the net I'm talking about. A pattern you can cut or fold to make a model of a solid shape. It is flat, but when you put it together, it becomes a 3D shape. It's kind of like putting together a puzzle. This is a flat shape right now. It's one-dimensional. But when you put it together and all 6 pieces are folded up, it will make a rectangular prism. So you have all of these pieces, fold them all together, and it will make the rectangular prism. And we're going to look at this more in detail in just a few minutes. What is surface area? The amount of area covered by the surface of a 3D shape. It is the amount of space on the outside of an object. If you look at this, this is a rectangular prism. The inside is not what we're talking about here. The inside would be the volume, how much something can hold, and we're going to discuss that in detail next week for our lesson. Surface area is the outside. It's all the space something takes up on the outside. Can you think of something that you might need surface area for? Maybe you would need surface area to find out how much paint you would need to paint a house so that you wouldn't overbuy or underbuy your paint. How about wrapping a gift? If you needed wrapping paper, you would need to know how much wrapping paper, especially if you were wrapping a really large gift. You wouldn't want to buy too little paper and then you didn't have enough to wrap your gift. That's the outside of a rectangular prism. Speaking of wrapping gifts, that leads us to our activity for today. Like I said, this is one of my favorite activities, and if any of my students are watching, we would have done this individually in class and all wrapped our own gift. My suggestion to you is, if you are watching this now, you might want to get some materials together. Oops, it skipped that page. Just one second. Which would be a roll of wrapping paper, scissors, a rectangular box, and tape. Those are the things that you would need to complete this activity. If you don't have those things on hand right now, you can watch this video tomorrow on YouTube, and you might can do this lesson yourself so you can pause the lesson as I'm doing it. It's a really fun activity to show you how to make a net for a rectangular prism. Now, what we're going to do at this time is we are going to pretend like there is a shortage of wrapping paper. We only can use just enough wrapping paper to cover this box. No more and no less. We can't have any of the box showing, but we can't overlap the pieces either. So we are going to have to draw a net for this box. No overage, no under. So I have my roll of wrapping paper, and I'm going to spread my roll of wrapping paper out. Forgot I taped it. There we go. Now, the way that we do this, how many pieces should I have when I'm done with this for my net? 6, because there are 6 pieces for a net of a rectangular prism. So what I'm going to do, let's put this notebook here so the paper will stay steady, is I'm going to draw the net. You can start with any side. I like to start with the larger piece first. I'm going to put this bottom piece, remember we have a bottom first, and I'm going to trace my bottom. Remember, I am building a net. Next, I'm going to flip it to the back. So this is bottom. And now I'm going to trace the back. Now I'm going to turn it to the top. This one was back. You might want to label your pieces just so that you keep them straight. Now this is the top. This is the front. You're just rolling it over to get all of these pieces. Oops. Now go back up to the top. And what you're going to do is you're going to roll it, and you're going to do the side. That's side 1. And this is side 2. You can do this with any size box. It can be small, it can be large, any box you have at home. So that's side. And then this is a side. Then you're going to get a pair of scissors and you're going to cut your net out. You are not cutting each individual piece out. For time, I have already cut one out. And it looks like this when you're done, which is exactly like this one. Okay, so this is your net. Now, this is the fun part to see if it actually works. I'm going to use this. Remember, we can only have just enough to wrap it. No under, no overage. I'm going to use this to wrap my box. So, this is the top, so I'm going to put the top right here, and then I'm going to fold it and pull it as tight as I can and put my tape on right here. If you want to put another little piece of tape there so it doesn't flap up, that's fine. My front is right here, so I'm going to pull that up right there. My side is right here, so I'm going to pull this up right here. And my other side is right here. So I'm going to pull this one up and tape it. Now just think of how much money you can save your parents on Christmas wrapping, and you won't waste a bit of paper and birthday presents and anything else that you are doing. So see how this is perfectly wrapped, and we didn't waste any wrapping paper. This is a net. This is how you can find surface area. Every rectangular prism has a net. Now I want to show you a formula for finding the area of a rectangular prism. This is all great. This is fine, but we're not always going to have time to stop and draw a net for every single rectangular prism. This is just a way for you to understand what a net is and what a rectangular prism is made up of. So, we are going now, what can we conclude is the best way to find the surface area of a rectangular prism? Okay, first of all, we know the top and the bottom are the same measurements, correct? And then we know the front and the back are the same. So they would be the same measurements. And we also know side 1 and side 2. This could be side 1 and side 2. It really makes no difference. They are the same, so they're going to be the same measurement. So I want you to take a minute and think. If we could get the measurements for every single side, what could we do to find the total surface area of this box? We could add them all together. So let's look at what I've put up here. If you take the front piece and the back piece and you say, where's my little pointer? Well, I could just do it with my finger. Okay. If I take the front piece and the back piece and I say length times height, which is area, wouldn't that cover that whole thing to do length times height? If I find the length times the height of this figure, then I will be able to find the area of that front piece. And then I can multiply it by 2, and that takes the front and the back. This and this on this particular shape. Then, if I take the 2 side pieces, I can take the width times the height, because here's a side and here's a side. There's the height, there's the width, which makes up the 2 side pieces. And I can get the area of this side and this side. So I would say height times width, and I multiply it by 2 because I have 2 sides. If I just do one of them, then I'm only finding the area of one side. I need 2 sides. And then if I do a top and a bottom piece, then I can do length times width, because that makes up the top and the bottom pieces. So I do length times width, and then I multiply it by 2, because I've got to include both pieces. So let's look at this formula. Using the formula, we are going to find the area of this rectangular prism. The width is 5 meters squared. The length is 10 meters squared. And the height is 6 meters squared. Okay, so what I've done is I have reposted the actual formula that we're going to use. Okay, and let's look at it on the board together. Okay, so now we're going to look first at the front and the back. Okay, here's the front, here's the back. So our formula says length times height, but don't even think about it as formula. Think of it as here's the front, here's the front. This piece right here has absolutely nothing to do with the front piece. Look, it's right here. That has nothing to do with the front piece. So it's the 10 and the 6 that make up the front piece. If this is 6, what is this going to be? It's also going to be 6. If this is 10, what's this going to be? It's also going to be 10. So we can say 6 times 10 to get the area of the front. So we can say 6 times 10, and that equals 60. But we have a front and a back, so we need to multiply it by 2. So we get 120 for that front and back. That's both pieces, the front and the back. Okay? So the next thing we want to look at, and it really doesn't matter which order you do these in, it makes no difference because you're still, when you're adding, you're going to get the same answer. 2 side pieces. We're going to use the width and the height because look, the length has absolutely nothing to do with the 2 side pieces. So we're going to do 5 times 6 because if this is 6, this is 6. If this is 5, this is 5. So we're going to take 5 times 6 for the side pieces. This is side 1 and side 2. So it's 5 times 6, 5 times 6, which equals 30, times 2 because we have side 1 and side 2, and that equals 60. So far we have 120 and we have 60. Now we're going to look at the top and the bottom. We have the length and we have the width. The height has nothing to do with this with the finding the top and the bottom. It's not connected. The pieces have to be connected in order to use them to find the area. So we're going to say 10 times 5. 10 times 5 equals 50, and this is for the top and bottom. I have all of this listed right there as well. And we have a top and a bottom, so we're going to do it times 2, and we get 100. Okay, now we have these 3 numbers, but we can't have 3 answers. This is for each 2 pieces, 2 pieces, 2 pieces. And remember, we have 6 pieces for a rectangular prism. So what we're going to do at this point is we have to add all 3 of these pieces together to get our full surface area of our rectangular prism. So we're going to take 120 plus 60 plus 100, and you get 280 meters squared. And your unit is always done in square units, just like regular area. It's not cubed, it's squared. So 280 meters squared is our answer to this problem. I'm going to try one more with you, and as another example problem. So I want you to do this along with me. If you have a piece of paper and pencil handy, I will go rather slowly so that you can have time to do each step with me to have a sample problem, because I know your teacher will be giving you some work to do on her page, and you can use my samples to work out your problems. Actually, let's use the real dimensions of the box that we just did. Okay, so I have a tape measure. I have the length as 7. So we're going to write L equals 7 inches. The height of this box it's about 3. So it's 3 inches. And the width of this box is about 6 inches. Okay, so I'm going to kind of sketch it. Okay, so the length is 7, the width is 6, and the height is 3, okay? And these, of course, are all inches. Let's see if I can find a pen that's a little darker. Okay, so the first thing with length, it tells us, or the first thing to find the length, we're going to do, or the front and the back, I'm sorry, we're going to do length times height. So 7 times 3 equals 21, but remember, we've got to do the front and the back. So times 2. The biggest problem I see on students' work is that they forget to do the times 2. Just don't forget to do the times 2. So when you do times 2, you get 42. And that's right now, it's just 42 inches. Okay, so the next thing, actually it is inches squared. Okay, the next thing is the 2 side pieces. The 2 side pieces are going to be width times height, because there's the width, there's the height. So it's 6 times 3 equals 18. Then you're going to do times 2, which gives you 36 inches squared. And then the next thing we're going to do is the length and the width to get width to get the top and the bottom, which is 6 times 7 equals 42 inches squared. So remember, at this point, we're going to add up our 3 answers. And when we add these up, we get 120 inches squared, and that is the actual surface area of this box. 120 inches squared. Well, I have really enjoyed doing surface area with you today, and I hope you were able to learn a lot, and you can go back and do your own surface area wrapping paper activity, and you can do some extra problems to strengthen your skills. Next Tuesday at 8:30, I will be on the air going over volume of rectangular prism, and we're going to use some cubes and other activities to learn about that. It was so nice working with you, and you have a fabulous week.